Down a little bit. This is the last time for this course. So for the last time, we are going to complete data analysis required for this course, and we are going to talk about the remaining part of the confirmatory function analysis, and then we transfer to structural modeling. Then we transfer to mediation analysis. Okay, so now this is what we say. This is the measurement model, and we already know how to test the measurement model and where to find the criteria for the measurement model. And besides this, we also have to compute composite reliability, average variance extracted, and which is AVE. I already mentioned that, right? I talked about that. Yeah, the AVE, and also as well as the square roots of AVE. Yeah. CR, composite reliability, is used to confirm what? Composite reliability, CR, it is for reliability, and ABE, this is for ABE is used to confirm what? Convergent validity. Convergent validity. And the square roots of ABE. Square roots of ABE is used to confirm discriminant validity. So this is but now the next question is how to compute these scores. How to compute the scores. It's very complex. But now I show you a very easy style, easy way for computing the scores. There is a you see this one. This is but it's only in Chinese. It's only in Chinese, but I can explain what they are. Here, this is what? This is the number of the atoms, or the number of the indicators. So you can see 1, 2, 3, 4, 5, 6. It means the number of the indicators. For example, if I choose 3, then you can see 3 blanks in here. You need to input the factor loadings of the 3 indicators. If you input the factor loadings, you take this one, compute. This will automatically compute composite reliability and average variance extracted AVE. It will compute CR and AVE for you. Is that clear? Is that clear? Yeah, so it's very easy. It's very easy. So now you know when we compute CR or AVE or square root of AVE, what is the focus for this analysis? What is the focus? The focus is factor loadings. Factor loadings. Okay, now let's use one example to illustrate how to do this. Okay, so now I'm going to compute CR, AVE, and square root of AVE for A. For A. I'm going to compute CR, AVE, and the square root of AVE for A. What is the first thing for the data analysis? If we want to compute the scores, what should we do first? What should we do first? We use what? For the data analysis, we use what? Factor loadings, right? Factor loadings. So now if I want to compute the CR and the AVE for A, I have to find out factor loadings of these indicators, right? Yeah. Okay, so now let's do the analysis. Okay, do the analysis. Then you tick this one. So if you tick this one, you can see the values in the model. But I told you all of these values are unstandardized values, unstandardized estimates. We need standardized, right? We need standardized. So we take this one. This is standardized. And then probably you can see that for each indicator, if you take this one, you can see a right arrow, right? You can see it becomes right. And along this red arrow, along this red path, you can see a number, you can see a coefficient. Yeah, this coefficient is the factor loading. It's the factor loading. So for each line, for each indicator, you can see a score, you can see a number, you can see a value. All of them factor loadings for each atom. For each atom. But the problem is the values are too small to see them, right? They are too small. So when you have a very large model, they are too small to see. So you need to know, we need to go text. Go test, you can see estimates, you open it. Then you open scalars, estimates, scalars. Then you go to standardized regression weights, standardized. You take this one. So here you can see all of the scores. For example, A. We have 6 atoms for A, right? 1, 2, 3, 4, 5, 6. 6 atoms for A. You can see 6 estimates in here. 6 estimates in here. All of them are factor loadings. So you can find factor loadings in here. So what? The first thing, we need to find the factor loadings. What's the next? What's the next? The next is we have to input these factor loadings in this computer, right? Yeah. So we input them. So for this one, 0.58. So we have 6 indicators. So we choose 6. The first factor loading 584. 584. The 667. Yeah, 667. 837. Yeah, 837. Yeah, and 789. Sorry, 792. 792. Okay. This is 485. 485. So actually, you know what is the minimum level, or what is the criteria for factor loading? The minimum for factor loading. 0.5. 0.5. 0.5. This is the lowest requirement for factor loading. And some scholars even demand that factor loadings should be above 0.6. 0.6. Let me see. You can see here. And all of the individual atom loadings exceeded Chin's suggested minimum value of 0.6. That's the lowest. The lowest. So I shared this article with you, right? Yeah. So actually, this factor loading below the requirement, below the threshold. Yeah. So actually it should be removed. It should be removed. But no, we don't do that because I just tell you how to compute CR and AVE. You know that. So in your own data analysis, when you encounter this problem, you need to know how to deal with that. You need to delete this atom. It's too small. Okay, this is this one. And next one, 0.614. Okay, now I already input the 6 factor loadings, I can compute. Now you can see this is for composite reliability. This is for composite reliability. This is for average variance extracted, AVE. So for A, for this variable A, its CR is 0.8. 0.8. For AVE, it's 0.45. Okay. Now we know. See, later we are going to talk about square roots of AVE later. Now we talk about CR and AVE. Okay, this is the values for CR and AVE. So the next question is, what is the criteria for CR and AVE? What is the criteria? So remember this. CR should be above 0.6. CR should be above 0.6. AVE should be above 0.5. 0.5. Okay. Okay, now let's check CR. Does the CR meet the requirement? The CR meets the requirement? Yes. Yes. It's 0.8. It's larger than the requirement. How about AVE? No. It's below. Below the criteria. It's below. So this is a problem. This is a problem. So you have to know when you compute the CR AVE, AVE is not that easy. So it's not easy for us to meet the requirements of AVE. So if you want to meet the requirements, your data analysis, your factor loadings should be large enough. Should be large enough. Okay, how about this? Suppose we delete this one. We delete this one. So we have not delete. So we use another large factor loading. Suppose it is 7. 7. 0.7. Let's see. You can see it's almost reaching the criteria. Almost reaching. Suppose it's 8. 0.8. You see, it's above the criteria. So how can we meet the requirement for CR and AVE? You should have large factor loadings. If your factor loadings small, it cannot meet the criteria. Okay, so this is how to compute CR and AVE. Next, let's talk about square roots of AVE. How to compute the square roots of AVE? How? How to compute that? You can use calculator. It's easy, right? Just use calculator. Then you will know the square roots of AVE. square roots of ABE should be larger than square roots of ABE should be larger than intercorrelations. Intercorrelations. Now let me explain. Can you understand what is mean by intercorrelation? Can you understand that? No. Okay, now let's explain. Okay, now let's change back to 8584885. Okay, so ABE is 0.45, right? Okay, and of course it's below the criteria, but we just ignore that because we just want you to understand how to evaluate square roots of ABE. Yeah. Now can you compute what is the square root of the ABE square root of 0.45? Compute that. Use your calculator. Use your calculator. What is the square root?
0.6.
0.67, right? Yeah. Now, square roots of this ABE is 0.67, right? And now, just now I said that this square root should be larger than intercorrelations. What does it mean by saying intercorrelations? It means the correlations of this variable with all other variables. This is intercorrelation. Again, okay, I will show you. I will give you one example to see what it is. Now you just remember, intercorrelation, it means what? It means correlation of a certain variable. Correlation of a certain variable with all the other variables. All the other variables. This is intercorrelation. Yeah, this one. Okay. So now, when I say intercorrelations of A, it means correlations of A with all the other variables. So it means what? Correlation of A with B, C, D, E. How to compute correlations? Here, right? Correlate. And I think you can remember that. Yeah. So I put all of them. Okay. So now I compute this one. Okay, so now you can see this is the correlation, right? When I say correlations of A with all the other variables, what does it mean? Which this one, this line, this column is the correlations of A with all the other variables, right? This is a correlation of A with B, right? This is correlation of A with C, correlation of A with D, correlation of A with E, right? Now I say the square root should be larger than the correlations of A with all the other variables, which means the square root should be larger than these correlations. Is that clear? Yeah, that's it. That's it. But what's the result? So the square root is 0.67. It's much larger than all these correlations, right? So no problem with square root of ABE. Okay, so now for A, for this variable, it's CR, no problem. Square root of ABE, no problem. But ABE, problem, right? Yeah, so in this case, for example, you should delete some items which has small factor loadings. Then your ABE will be improved. Yeah, that's it. That's it. So I give you one example to illustrate this. Here you can see okay, now you can see this is the result, right? This is the result. And the first part, descriptive, correlation, and confirmed two-factor analysis. Confirmed two-factor analysis is what we are talking about right now, right? Yeah, so now let's take a look. Okay, this is about CFA. Okay, read this part, try to understand. You can see factor structures of the measures by conducting a CFA comprising 14 factors. This measurement model has 14 factors, right? 14 factors. Okay, so this measurement model fits the data well. What? This is what? This is model data fit, right? CFA, RMSEA, we talk about that a lot. Yeah. This is chi-square. This is degree of freedom. And but I don't think this is a good way of reporting indices, because we have to compute the ratio by our own. Yeah, so the chi-square is this one. The degree of freedom is this one. So the ratio is what? The ratio is around 4, right? Around 4 divided by around 4, right? Yeah, around 4. It's below the criteria of 5. Right? Can you remember this? Chi square, the ratio, chi square and the degree of freedom. Yeah, it should be smaller than 5. Yeah. Okay, it's smaller than 5. And then you can see RMSEA. It's okay, right? Yeah. CFI, it's okay, right? CFI, oh, it's okay. NNFI, just TLI. It's also okay. Okay. Next, you can see all of the factor loadings greater than 0.6. The criteria. Yeah, 0.6. What? Then you can see it mentioned AVE. AVE. The AVE of all constructs over 0.5. Here, it should be about 0.5, right? Yeah. Okay, 0. And square roots of AVE greater than the intercorrelations. Greater than the intercorrelations, indicating acceptable discriminant validity. I can show you. Where is it? Right. Here, right? Yes. Cannot. Yes. Okay. Can you tell me what it is? What it is? Correlation. Good. Correlation. Correlation. Can you tell me? Try to guess. What is the value in the bracket? What is the value in the bracket? Normally, this value should be 1, right? Because this is the correlation between the same variables, right? Normally, it should be 1, but here, there is a value in the bracket, not 1. Can you take a guess? What is this value? This is the square root of AVE. This is square root of AVE. Can you see here? The diagonal line is the square root of AVE. Why we report square roots of AVE along the diagonal line? Why we report the square roots this way? Because it's easy for us to compare the square roots of AVE, and this is the intercorrelations, right? Yes. So it's easy for us to compare. Of course, we can see this square root is larger than all of these intercorrelations, right? So no problems. No problems. So what does this mean? I show you this. You need to know when you report square roots of AVE. This is a good way. Okay. Okay, you can see here. Okay, that's all. Next, so the values of Cronbach alpha coefficients and the composite reliability, CR, CR for all scales were no less than, but because their scores above 0.8, but the criteria is 0.6, 0.6. So now this is the whole process of testing confirmatory fraction analysis. Yeah. So now you need to know how to do that. Now, okay. So this is the whole program. I will share this article with you. So when you do your own data analysis, when you report your own values, you can imitate this article. Okay. So this is now we complete confirmative factor analysis. Yeah. Complete that. Now we are going to transfer to structural model. For structural model, maybe we need to use the other data. That's easy for you to better understand the structural model. So I use another model, another data. So I construct the model all over again. For that data, we have a bridging social capital. This one. So bridging social capital has 6 indicators. 6. 1, 2, 3, 4, 5, 6. Okay. For founding social capital, also 6 indicators. For efficacy, it has 10 indicators. Or more. This is 10. 5. Yeah. And for leaders of the path, it has 4 indicators. 5. Oh, 5. Yeah. Yeah. And for research motivation, intrinsic research motivation, it has 5. Yeah. It has 5. For extrinsic research motivation, it has 3. It has 3. Okay. What is the structural model for this data? We use the 4 as independent variables, right? We use the 2 as dependent variables, right? So they are examined as the predictors of intrinsic and extrinsic motivation. Yeah. So now data. Okay, so next I name, this is, this is bridge, right? This is bridge. This is bridge. This is bound. This is bound. This is efficacy. Huh? This is bound. This is efficacy. This is support. This is support. This is intrinsic. This is extrinsic. This is extrinsic. Yeah. Okay. Now I name this residue errors. Okay. Then I draw. So what is a structural model? Structural model contains hypotheses, right? Yeah. So I use predict intrinsic. I use to predict extrinsic. Extrinsic. What I should do next? I should add the residue errors for words too long. Yeah. Here. Cannot find the right place to add the residue error. Okay. Then I name them. Okay. Then rotate. Okay. What else? What else? I should add covariances between the predictors, right? Yeah. So covariances. Okay. What should I do next? What's next? What's next? I should add covariance between them. Right? That's all. Now I can compute. I can. Oh, I have to save. Now we're computing. Okay, so these are the data analysis. Okay, so you can find the result. Here, model data feed. Is that okay? The model data feed. Chi-square. It's okay, it's good, right? Chi-square. CFI is acceptable, right? TLI acceptable, right? Yeah. RMSEA acceptable, right? Yeah. So model data fit, no problems. Now I go to results. This is the result. This is the hypothesis, the findings about the hypothesis. Can you tell me which of them are significant predictors? Which are predictors of intrinsic and extrinsic motivation? Find p-values. P-values. Your bridge, positive predictor of intrinsic, right?
Yeah.
Right?
Yeah.
Yeah. And bound, is it significant?
No.
Bound, not significant. Efficacy significant, right? Support significant, right? Yeah. And for extrinsic motivation, bridge significant, right? Bound significant, right? Bound significant.
Yeah.
It's a significant, right? But pay attention, is negative predictor. It's negative predictor of extrinsic motivation. Did you see that? Yeah. And efficacy and support, positive predictors of extrinsic motivation. Yeah. That's it. That's the result. Now I show you. Oh. I forgot to tick these ones. Yeah. Again. Okay, still model data fit. Still the results. Now I show you where to find the coefficients. You go here. You can see scalars. Scalars. See scalars. Regression weights in here. All of them are unstandardized estimates. These are unstandardized estimates. When you go here, all of them are standardized estimates. They are standardized. When you find covariances, what is covariances? Correlation. It's correlation because you can see there is what? No, this is double arrows. So this is correlation, but this is what? This is unstandardized correlation. Unstandardized correlation. When you go here, correlation. This is standardized correlation. So pay attention. Unstandardized, standardized, unstandardized, and standardized. Yeah. I show you this because in this model, sometimes it's hard for you to find the values. Sometimes the values are too small. So you need to, in this case, you need to go over here to find the values. All of them are here. All of them are here. So this is what? This is structural model. This is structural model. Okay, that's it. That's it. Now we are going to talk about the last important thing, which is mediation. Which is mediation. Close this one. Good. Suppose can you distinguish the four predictors? Can you distinguish them? Are they different? The four predictors, are they different? Of course, apparently they are different because bridging social capital, bounding social capital, leader support, they are contextual factors, right? Social capital, leader support, they are environmental, they are contextual factors, right? Yeah. Efficacy, self-efficacy, this is personal factor, right? Okay. Now I want to change this model, change this model to a mediation model with environmental factor as the predictors, with the individual factor as the mediator, with motivation as the outcomes. Do you understand me? Yeah. So in the mediation model, bridging social capital, bounding social capital, and the leader support, they are predictors. Efficacy, this individual, this personal factor as the mediator, and research motivation as the outcome. So now I need to change the model. Okay, so I move efficacy. Oh, sorry. I move efficacy here. Okay, so now they are predictors, right? Efficacy, mediator. So now the model changed. We use predictors pointing to mediators, right? Mediators. And we use mediator pointing to outcomes. Also, Okay. That clear? This is the mediation model. Now it's the mediator. It's the mediator. It may mediate the relationship between the three contextual factors with the outcomes. Yeah, that's the mediation model. Mediation model. Can you tell me how many mediation paths in this model? How many mediation paths in this model? How many mediation?
6.
6. Any other answers? How many? 6. 6, right? This is one path, one mediation path, right? This is a second mediation path, right? This is the third one. This is the fourth one. This is the fifth one. This is the sixth one. So altogether, we have 6 mediation paths. But we not sure. Are they significant? They are potential mediation paths. We don't know whether they are significant. So we have to conduct mediation tests. So now I show you how to test mediation. First of all, you have to go to analysis. You can remember in here we previously used the functions in the output. If you want to do the mediation test, you have to go over here, bootstrap. You have to go over here, bootstrap. We use bootstrap method in testing mediation. So here you perform bootstrap by 2000 times. You change it to 2000 times or 5000 times to 2000 or 5000 times. But here I just use 2000 because if you use 5000, it's going to take longer for analysis. 2000. Okay, then you pay attention to this. The key in mediation, the key is confidence interval. We use confidence interval as the criteria for mediation test. It is key value. And we use 95% confidence interval. So remember this value. 95% confidence intervals. 95% confidence intervals. This is the value for evaluating mediation. Okay, so this is 2000, this is 95. That's okay. That's okay. Now we can compute again. So this time, this data analysis, this data analysis is for this mediation model. Now we compute. I forget what? Forget the correlation between the predictors. Okay. Uh, oh, what else? What's missed? Now, efficacy is the predicted variable. Previously, it's predictor, right? Now it's the mediator. Since it's a mediator, it's being predicted. So you need to add a residue error for efficacy. Yeah, and you have to name it. Okay, so now you can do it. Now it's begin. Take a longer time. You can see because it's bootstrapping. It's if you use 5,000 times, it's going to take much longer. Yeah. Oh, now it's finished. Okay. So now you can see the model data feed. Also, okay, right? The ratio is okay. CFI, okay. TLI, okay. And RMSEA is okay, right? Now, you can take a look at the result. What can you find? What can you find? You can see here, this is the one. This is a direct relationship. It's a direct relationship. You can see here, bridging to efficacy, bound to efficacy, support to efficacy. This is what? This is the relationship between the predictors and the mediator, right? Yeah. Next, you can see efficacy to intrinsic, efficacy to extrinsic. This is what? This is from mediator to the outcomes, right? Next, bridge, bound, support to intrinsic and extrinsic. This is what? This is from predictor to the outcomes, right? All of them are direct relationships. Now we are talking about mediation. Mediation. From here, we only know the findings about the direct relationships. We have no idea the mediated relationships, right? Yeah. So you cannot find the findings, the mediation results in here. Where can you find it? Where can you find it? It's in the place where it's not easy to locate. Can you see here? We have bootstrap. Bootstrap. But you can try to click them. They are inactive. they are inactive. So here, you have to go to matrix. Go to matrix. You open it. You open. Then you can see we have total effect. We have direct effect. We have indirect effect. Yeah. Why we have total direct and indirect effects in here? It's because we take this one. It's because we take this one, then Amos report total indirect and direct effect. Yeah. Okay, so you go to indirect effect. You take this one, you click this one. Indirect effect. You click this one. Now you can see it's activated. So if you don't go to here, if you don't click indirect effects, they are inactive. Only when you click indirect effects, they will become active. Okay. Just now I mentioned, what is the key for evaluating mediation? What is the key for evaluating mediation? What is the key for evaluating mediation? 95% confidence intervals, right? Yeah. You can see here, this is confidence. Then you take this one. So confidence intervals, this means it is a range, right? Confidence interval, it is a range. Yeah. So we have, you can see here, we have lower bounds. We have upper bounds. So you have to be clear. Confidence intervals. This is a range. There is a lower bound. There is a upper bounds. Upper bounds. So now I show you the criteria for evaluating mediation. Please remember this. Please remember this. When 95% confidence intervals does not contain 0. Does not contain 0. The mediation is significant. The mediation is significant. If it does not contain 0, it's significant. Mediation is significant. Then next. If 95% confidence intervals contain 0, the mediation is not significant. Because it's a range. When this range includes 0, it's not significant. Mediation is not significant. When this range does not contain 0, the mediation is significant. That's the criteria. So the next issue is what? Next issue, how to find the range, how to find the 95% confidence intervals, right? Yeah, how to find them. So it's easy, as you can see here. This is the lower bounds. This is the lower bounds here. Next. This is the upper bounds, right? It's for this. So we try to find what is the range, what is the 95% confidence intervals. For example, support to extrinsic motivation. Support to extrinsic motivation. What is the lower bound? Support to extrinsic motivation. Minus 007, right? Minus 007. This is lower bounds, right? Okay, so here it is minus 007, right? Okay. What is the upper bound here? Support to extrinsic motivation. What is the upper bound? 0.078. Okay. This is 95% confidence interval. Does it contain 0? Yes, it contains 0, right? So this mediation is significant or not significant? It's not significant, right? Yeah. Now let's go back. Let's go back. This is from support to extrinsic motivation, right? Support to extrinsic motivation. It means this mediation path. This mediation path is it significant? Support efficacy to extrinsic. This mediation path, is it significant or not significant? Not significant. Not. In other words, efficacy does not mediate the relationship between support and extrinsic motivation. Do you understand this? Yeah, great. Next, you can see here, bound to extrinsic motivation, bound to extrinsic motivation. Lower bounds minus 027, 023, right? Right? Then upper bounds, bound extrinsic, 107, right? So from minus, I forgot, from minus 023 to 107, does it contain 0? It contains 0, right? Yeah. So it means bound to efficacy to extrinsic motivation, this mediation path, not significant. Not significant, right? Yeah. Okay. We go further. Bridge to extrinsic motivation. Bridge to extrinsic motivation. The lower bounds 054, right? 054. Upper bounds 235. 235. From lower bounds 054 to upper bounds 235. Does it contain 0? No. So it means the mediation is significant. The mediation is significant. So it means bridge to efficacy to extrinsic motivation, this mediation part is significant. Right? Yeah, yeah. This is significant. Okay. Again, try to tell me, how about the mediation path to intrinsic motivation? To intrinsic motivation. For example, support to intrinsic motivation, minus 005, right? Yeah. From minus 005 to 071, right? It's not significant. Yeah, it's not significant. Okay, next, bond to intrinsic motivation. Bond, minus 017, minus 017 to 092, 092. It contained 0, right? Not significant. Last, bridge to intrinsic motivation 042, 042 to 222. It does not contain 0. It's significant. Yeah. Let's go back. So it means what? It means bridge to efficacy to intrinsic. This mediation path significant. Right? Yeah. Why? Because you can see bridge to intrinsic motivation, 042, and bridge to intrinsic motivation 222. It just means from bridge to intrinsic motivation, this mediation path is significant. It's a significant. Okay, now you can tell me. Altogether, we have 6 paths, 6 mediation paths. How many of them are significant? 2, right? Yeah. Specifically, from bridge to efficacy to intrinsic, this mediation significant. From bridge to efficacy, then to extrinsic motivation, this mediation path also significant, right? Yeah. Okay. Only these 2 mediation paths are significant. All the others are not significant. This is how we test mediation. Okay, so when you use this way for testing mediation, use this way to test mediation, you need to cite this article. You need to cite this article because Schwartz, Borger, they find this way for evaluating mediation. Okay, that's it. That's it. Can you see here? Okay, from here, you can see regarding the indirect effects, okay, so indirect effects, student engagement mediated the relationship between course experience and the generic skills development. What does it mean? It means student engagement is a mediator, right? between course experience and the generic skills. Then followed by beta value, and followed by 95% confidence interval. Why? Because this interval from 2 to 3, 5, because it does not contain 0, so the mediation is significant. Yeah, that's how you report the mediation. Okay, that's it. That's how we test mediation. Always been for this for almost for about for the whole semester, always been talking about data analysis. But what I'm trying to tell you is that data analysis can tell us a lot of things about education, about social phenomenon, about the nature of education and the social phenomenon. We can learn a lot from the data analysis. I shared this data analysis I shared with you only threshold, the minimum data. We have many other data analysis. They can reveal many complex relationships, like multi-group analysis, like multi-level analysis, like cross-select data analysis, many data analysis. So when you know this data analysis, when you learn others, it's easy for you to learn other data analysis. But even though these data analysis are the common data analysis in our studies, maybe when I try to explain them, you can understand. But when you conduct this analysis on your own, you will encounter many problems. So what is the key to solving these problems? What is the key to solving these problems? You need to practice. You need to use them. You need to use them. That's it. Yes.
Thank you. How important is this modeling in coming up with my conceptual framework? For example, if my original conceptual framework in the model did not contain mediation, and then I decide to test for mediation using this modeling, then I find that there is significant 5% confidence interval in the mediation. Does it mean I have to go back and redraw my conceptual framework? In my proposal, I come up with my conceptual framework.
Yeah, the conceptual framework contains mediation hypothesis. That's it. Contains mediation.
Let's say it doesn't. It doesn't.
Okay.
But then I conduct this test, and then I find that
So you additionally
yes.
find mediation.
Yes.
Okay. If we, in that case, you need to find support for your mediation. The support, for example, theoretical support. Some theories may support there might be a mediation hypothesis among these variables. You need also find empirical support for the mediation. The empirical support means prior studies also examined the mediation, similar mediation. Yeah, so their findings, these prior findings, can also support your mediation hypothesis. All in all, you have to find support for your mediation hypothesis. If you can find such support, you can change your conception model to the mediation model. You can do that. Only if you can find the foundation, the rationals for the mediation, then you can do that.
If you don't find it.
But
And if you don't find it means you cannot.
if you cannot find support, you can still examine the mediation, but you need to try to explain that. You have to convince others there might be a mediation. It's going to be hard. If you can find theoretical support, you can find empirical support, it's easy for you to convince others. But if you cannot find such support from five studies, then you need to try to explain that. Yeah. Why there might be a mediation in there. You need to try to explain that. It's going to be harder, but it's still possible. You try to explain that. You have to ask others. Believe what you say. You think. Okay, that's all for the data analysis. Now I will tell you the final term paper. Musa, can you say something in our group? Say something in our group. Okay, so this is the only change is that you have to submit your final term paper before August 15, 2026. Now you can see this is 2025. 2026. It's not possible. Okay, so before August, this is the summary from Musa last year. Yeah, so you are supposed to submit your final term paper before August 15, 2026. Okay, that's it. Using this data, using this data for the data analysis, you have to report the whole process of the data analysis. Yeah, that's it. Okay. The final thing, the final request, some of you or many of you filled in the questionnaire for the first wave of data collection. Now we are collecting the second wave of data collection. So please, if you filled in the first wave, please now, if you can fill in the second wave